All right, so finishing up. All right, we're into these applications, and this first one we're talking about the pH scale. So the pH scale of a solution is defined to be the negative log of H subscript 0O plus, right? So this is 3 hydrogens and an oxygen for you chemistry people or you chemistry folks, right? Where H30 plus is the concentration of hydronium, all right, ions in units of moles per liter. Solutions with the pH less than 7 are said to be acidy or acidic, while those with a pH greater than 7 are basic. All right, so basically we're just going to take this formula and just have the negative log in front and just multiply this out. All right, and then this is just your scale, your pH scale, and so you get a pretty good idea of if you have heartburn, like you should know what to stay away from based off these pH levels. And so if a sample of orange juice is determined to have a H30 positive concentration of 1.58 times 10 to the negative 4 moles per liter, what is its pH? Well, basically the formula just told us to just take the negative log and plug in this, right? Plug this in for plug this in for the concentration, because that is the concentration. So all we're going to do, we're just going to plug that right into our calculator, times 10 to the negative 4, right? And so we're going to say negative log 1.58 times 10 raised to the negative 4. And we will get a pH of 3.80134, right? Which, based off that scale, we probably just want to round it maybe 1 decimal, so 3.8. So that's how much pH would be in this orange juice. So approximately 3.8. Right? And so it makes sense for this negative log to be there, right? Because if not, this is going to end up being negative. And so a negative times a negative is giving us that positive pH. All right. So again, just plug in your concentration with the negative log. All right. Here it is. So after doing this calculation, the reason for the minus sign in the formula is more apparent. By multiplying the log of the concentration by -1, the pH of a solution is positive, right? Alright, so we also will have our decibel scale, and the decibel scale where I means intensity. This sub-zero just means your initial intensity. Discernible sound, I is the intensity of the sound being analyzed, and D is its decibel level, right? So you're looking for the decibel level based off of this formula, and decibel levels range from 0 to barely discernible sound to 40 level. All right, so it's just telling us what's bad and what's good. So it says, given your initial intensity of 10 to the negative 12 watts per meter squared, what is the decibel level of a jet airliner's engines at a distance of 45 meters, for which the sound intensity is 50 watts per meter squared? So little misleading as far as with the verbiage, right? So remember what the formula says. So the formula says decibel can be found by taking 10 log base 10 of your intensity divided by your initial intensity, right? So our intensity is right here. So this 45 means nothing to us as far as this formula is concerned. All right, so we have the initial intensity, and then we have the intensity. So basically, this is just going to be another plug this into your calculator type of a deal. So you're going to say log, and then you're going to say 50 divided by 10 to the negative 12, right? Which, if you think about this, like I said, you can plug this straight into your calculator, but you can also play around with this a little bit. This is really 10 log of 5 times 10 times 10 to the positive 12, right? Because I can just move that up, and that's to the first. So this is really saying, I mean, I'm just kind of getting silly with this, but you can see, right? So I'm going to just type this in, though. So got the coefficient 10, and then log, and then 50 divided by 10 raised to the negative 12. And we have, well, I said that's supposed to be 10, not 1. So 10 log argument of 50 divided by 10 raised to the power of negative 12. It's about to say, I'm pretty sure jet is a little louder than that. And we get, oh, I put times. Jeez. So 10, third time's a charm. 10 log 50 divided by 10 raised to the negative 12. And there we go. So 136.9897, right? Which on the decibel scale, that's loud. All right, so hopefully this has been a helpful PowerPoint as you continue to work through chapter 5.4. But stick around because we will do a quick Panopto video on some of the practice questions. All right, talk to you soon.